Hey, today we talked about using right triangle trigonometry to find the missing side lengths of any right triangle. We went over our 45, 45, 90 triangles, and we talked about how we have the two formulas, leg equals leg, and hypotenuse equals leg root 2, and then we talked about our 30, 60, 90s, and we have the hypotenuse equals short leg times 2, and the long leg equals the short leg, root 3. And we talked about those formulas, but then we said, what are we going to do when we don't have a 30, 60, 90 or a 45, 45, 90 triangle? And this is where your right triangle trigonometry will come into play. So just as a review over some terminology, we have what's known as the hypotenuse. It is the longest side of a right triangle, and it's always opposite the right angle. So that hypotenuse is always opposite the right angle. When we talk about a side that's adjacent, we talk about a side that it's adjacent to a specific angle, we don't talk about the 90-degree angle very much. So we're talking about this side right here would be adjacent to angle A because it helps form that angle and it is next to the angle. We talked about opposite the angle, so opposite the angle would be this side. And then we talked about, well, what happens if we have angle B? This side here becomes known as adjacent to angle B, and this side over here then becomes opposite to angle B. Fortunately, the hypotenuse will never change. It's always the longest side, it's always the hypotenuse. So we learned SOHCAHTOA. So in our SOHCAHTOA represents sine of an angle, and sine spelled S-I-N-E, but we use S-I-N as the abbreviated word for it, and it's not sin, but it's sine, and we say sine of an angle is equal to opposite, that's where that O comes from, right there, over the hypotenuse. So according to our picture, if I'm talking about sine of A, opposite of A would be little a over the hypotenuse, C. We have cosine, that's the ka in our SOHCAHTOA. Cosine, and it's actually spelled cosine, C-O-S-I-N-E. We abbreviate it cos. Cosine of A is equal to the side adjacent to angle A over the hypotenuse. So we could actually say it's equal to B over C. And then our last one, tangent, is of the angle A is equal to our side opposite A. That's where that O represents. So little a over here over the adjacent side to angle A, which would be B. And then I wanted to talk about, well, what if we actually talk about sine of angle B now? It would be the side opposite. In this case, it would be B over the hypotenuse C. Cosine of B would be our adjacent side to angle B. So that would be A over the hypotenuse. And then tangent of angle B is equal to the side opposite over the adjacent, so B over A. And if we can remember that our trig functions, sine, cosine, and tangent, are always to find that an angle is equal to a relationship of two sides of the triangle. That might be helpful. So we practiced our using our calculator. Before you can use your calculator, you need to make sure the mode has been changed to a degree for what we're going to be using today. Once you have put in a degree mode, then we can just type in sine. We have a button on our graphing calculators that says SIN. We just press that and type in 60, and we get 0.866 or 0.87. And remember that sine of an angle is always a relationship of the opposite side over the hypotenuse. So with cosine, when you type in cosine of 15, and that's the COS button, you get 0.9659, so 0.697. And remember that cosine is always a relationship of the adjacent side over the hypotenuse. So then we talked about, will these values ever be bigger than 1? We said because the hypotenuse is always the longest side, and it'll always be the biggest number on the bottom of our fraction, it's on the bottom of our fraction, then this value right here will never be greater than 1. So with tangent, when you type in tangent of 67, we get 2.355, so 36. We're going to round to the nearest hundredth, by the way. When you type that in, we talked about that this is always a relationship of an opposite side to an adjacent side. And so here, in this case, could the opposite side be bigger than the adjacent side? Yes, and that's why this number could be greater than 1. It could also be less than 1. Okay, here's where we use it. When you're asked to solve each triangle, the first thing you have to do is find all of the angles and all of the sides. So the first thing we talked about is, because we have a right triangle, we know that these two angles are complementary. That means they add to be 90 degrees because this angle is already 90 degrees. So because they're complementary, we can take 90 minus the 22 to get 68 degrees here. From there, I always tell my students to use the angle that was given because we haven't made any mistakes with that angle yet. And I'm going to say, what side do we have in relationship to this angle? We have this side, which is known as the opposite side to angle 22. So what two functions, if we write out that SOHCAHTOA, which two functions involve the opposite? We have sine and tangent. So we're going to have two equations. The first one I'm going to say sine of the angle that we have, so sine of 22 degrees is equal to your side opposite over the hypotenuse. In this case it's C. And the fast way to do this is to multiply by C. Or I shouldn't say the fast way, but I'll show you in a minute. And then to get C by itself, we would divide by sine 22. And then you would get C equals 8 divided by sine 22. And at this point, you would go to your scientific calculator to calculate that. Or the really fast way to do this, and this is what I teach my students. If the variable that we're looking for is in the bottom of the fraction, then we're just going to swap places. So C equals, I forgot to erase that C. C equals 8 divided by sine 22. From there we can go right to our calculators and type that in, which gives us 21. I think we abbreviated to the nearest tenth, so 21.4. Okay, the other function that we talked about that uses opposite is tangent. So we'll take tangent of our 22 degree angle is equal to the relationship, or the ratio, of the opposite side. In our case, the opposite side to 22 is 8 over the adjacent side A. And again, the variable's on the bottom, so we're going to swap places. And A equals 8 over tan 22. We type that in our calculator, and we get 19.8. The other thing that we talked about, we said, hey, look at these two sides. Which one should be the longest according to our triangle? Well, of course it should be C, because C is our hypotenuse, the longest side. And so we checked to make sure that C was our longest side, and it looks like we're doing great. Okay, as we go to our second one, again, you can find this other angle really quickly, because we know that these two angles are complementary, so we just have to take 90 minus 64, which is 26. And then we're going to look at what side do we have in relationship to the angle that was given to us. So here it is the adjacent side. So in SOHCAHTOA, we have tangent that uses the adjacent, and we also have cosine that uses the adjacent. So we're going to use both of those functions. It doesn't matter which one you start with. If we start with tangent, tangent of our angle 64 is equal to the opposite, A, over 4. Now, to solve this, we would multiply by 4, and then we would just go to our calculator there. And I always tell my kids if the number's on the bottom, then we just move it to the front. So you get 4 tangent 64, which is the same idea as what I just did there by multiplying by 4. From here, we find out that a is equal to 8.2. Okay, the other fraction that we have that we can use is or relationship that we have is our cosine. We already identified that. We're going to take cosine of angle 64 is equal to the side that's adjacent, 4 over the hypotenuse c. And remember that when the variable's in the bottom, we can just swap places. So we get c equals 4 divided by cosine 64. We'll just type that in our calculator. And that gives us 9.1. Okay, here's our last one. Again, you can find this other angle because they're complementary, so we take 90 minus 18. We get 72. Then to find the sides, we're going to use that 18 degrees and say, how is 20 related to the 18? And it is the hypotenuse. So we have two functions that use hypotenuse. So we're going to set up our first equation. Sine of our angle 18 is equal to the opposite, b, over the hypotenuse, 20. When the number's on the front, we just stick it in front, and then we type that in our calculator. That will find b for us. B here is 6.2. Then we'll also use cosine. Cosine of 18 degrees equals our side adjacent, so a over the hypotenuse 20. Again, our number's on the bottom, so we are just going to stick it in the front. Put that in our calculator, 20 cosine 18. And that will find a for us, so a is 19.02, so 0.0. And the last thing you want to check is our hypotenuse really the longest side? And yes, it is, it's 20. Alright, the other half of this is if we are going to actually look for an angle. I didn't circle that very well. Angle instead of a side, we're going to use an inverse. So, I have here, and I will explain these in class next time, what we have here. If we're looking for angle B, and we're using the function sine, we're still going to take the opposite side over the hypotenuse, but if we're actually looking for the angle B, we take the inverse of sine. So remember that whenever you're looking for an inverse, whenever we're looking for an angle, you're going to use an inverse. Our fraction or our ratio still stays the same. It still compares those same sides that a sine would compare. So for B, if we're looking for, or if we're going to use cosine, then we would say the inverse of cosine to find B would be the adjacent side. So in this case, it would be the inverse of cosine of A over the hypotenuse C. And the last one, I just wanted to show you how these fractions look. If we were looking for B using tangent, so if we had the inverse of tangent, then we would take the opposite side. In this case, the opposite side is B over the adjacent side, A. And we would just use our calculator to find that information. So on our first one, it says use your calculator. Again, you have to make sure you're in degrees. So in our calculators, you have to do the inverse of sine. To do that, if using the TI-84s that we use in class, you would go second sine and then type in 1 divided by 2, and that will give you 30 degrees. When we do cosine, we take second cosine, or the inverse of cosine, and take 7 divided by 9. That will give you 38.9 degrees. And then for tangent, you'll just type in second tangent, or the inverse of tangent, 5 square root of 2. Make sure you arrow out or close a parenthesis. If it starts with a parenthesis there, you got to make sure you close it. And divide by 4, and you get 60.5 degrees. So here on example 4, we're going to use that idea. We don't have either angle A or B. So I'm going to tell you choose one. I'm going to say let's choose angle A and look at what we're given. We're given an adjacent side and an opposite side. So in our little formula, or our little help here, SOHCAHTOA, there is only one function that allows us to use both the adjacent and the opposite, and that's tangent. So when we go to set up our equations, or our equation, we're only going to use tangent. So we're going to say A equals the inverse of tangent. We're using the inverse because we are trying to find angle A is equal to the ratio, the inverse of tangent using the ratio of the sides opposite, in this case 8 over the adjacent, 15. And from here you just go to your calculator and type that in. Okay, so that should give us 28.1 degrees. And then from here we know that A and B are complementary, so we'll take 90 minus A, or 90 minus 28.1 to get 61.9 degrees. The last thing that you have to find is C. And to find C, we do know we have a right triangle, so we're going to use Pythagorean theorem. A squared plus B squared equals C squared. So we would do 8 squared plus 15 squared equals C squared. And I did have some kids today remember that this is a triple, and C equals 17. If you didn't remember that it was a triple, you could just finish that formula and find C. So here we go on B. I'm going to choose angle B this time. It really doesn't matter again which angle you choose, but choose one and then use it. We have the hypotenuse and we have a side opposite. There's only one function that uses both of those, and that's sine. So to find angle B, we take the inverse of sine of the side opposite, 4 over this hypotenuse, 12. And then you'll go to your calculator to find this angle. And in your calculator you should come out with about 19.5, and these are degrees, so we put degrees. Again, angle A and B are complementary, so we would take 90 minus B, so 90 minus 19.5 to get 70.5 for our angle. And then the last thing you have to find is A. So we're going to use our Pythagorean theorem. A squared plus 4 squared equals 12 squared. So 12 squared is 144, so you have A squared plus 16 equals 144. We're going to subtract 16 from both sides, and you get A squared equals 128. And then to solve for A, we take the opposite of squaring, which is a square root, and A gives us about 11.3. Okay, last one just as a good review. You're going to choose either A or B. I'm going to choose angle B. And I'm going to say which two sides do I have in relationship to angle B. I have an adjacent and the hypotenuse. And there's only one function that uses both of those, and that is cosine. Cosine is the relationship or the ratio of the adjacent side to the hypotenuse. And because we're looking for the angle, we will use that inverse. Okay, so when we type this in our calculators, you should get 36.9 degrees. And then to find angle A, we take 90 minus B, which gives us 53.1 degrees. And then the last thing we have to do is find B, so you'll take 16 squared plus B squared equals 20 squared. And 16 squared is 256. 20 squared is 400. And we'll subtract 256 from both sides, and you'll get B squared equals 144. Take the square root, and B equals 12. And some of you guys might have recognized that this was just a multiple of a 3, 4, 5 triangle. And if not, that's okay. You can still use that Pythagorean theorem, and it will help you find it. All right. That's your assignment, 10-4, right triangle trigonometry. Good luck.